In my last video, I built a prototype for an alarm clock. Now, I just happen to have this alarm clock lying around, and this thing hasn't woken me a single damn time. It's just not loud enough. But I thought it would be interesting to see what a finished product actually looks like on the inside. So without further ado, let's take this thing apart. As a first impression, this thing has way more buttons than mine. It's a very basic alarm clock, but I am interested what's actually inside. So let's try taking out the batteries. I think I just remove the batteries and then let's take it from there. Okay, I was kind of expecting there to be some screws. I actually don't know. Wait, huh? Okay, let me look this up. How to take apart electronics. Gather precision tools. It's done. Electronics without screws. Use thin plastic tools like guitar picks or cards to release internal snap clips. Apply gentle heat if the seams are sealed with glue. The seams. I do see a seam here. Do I have to heat it or can I just... Let me try cutting it. Alright, I found an X-Acto knife and let's carefully start prying. I can't really get in between here. Okay, I can see a gap forming. Let's just go around it. I don't think this is actually glued in. I think Google might be right and that there are snap clips inside. So let's try it with a pick. Right now I'm really wishing I used thinner picks. Let's try going at the side. Can I get it in now? This is a lot harder than I thought. I'm gonna try going around the perimeter one time. Okay, it might be glued on this side. I don't want to break the knife. That's the thing. You didn't see that? Okay, I got a flathead screwdriver. So let's try to pry this in between. Okay, I think I need a thinner one. This thing is glued tight. Maybe I'm being too gentle. Okay, I heard a click. Let's see, can I get my nails in between here now? Okay, now this side seems stuck. I really gotta be careful I don't cut myself. Okay, we're getting some funky stuff happening to the screen. My goodness. I feel like this is the only place where it's stuck. Ah, there we go. Okay, here I think it looks like I broke all the snap clips. Yes, that's true. Okay, so I think there was a way of just squeezing on the sides and then it would pop open. But hey, we got it out, so that's a win. First of all, I'm seeing these wires connected to the battery holders. Let's see if I can take this out. Okay, I don't think... Okay, I would have to cut these wires. Let's leave them on for now. We have this strange thing on the back, which is just folded. I think this might be the temperature sensor, actually. And just like my design, it has a tiny little buzzer, which is just not enough. But we are seeing some screws. So let's whip out the screwdriver. Let's loosen these screws. Yes. Okay. That's one. That's two. All right. So that's all the screws loose, just like me. It has one little peg holding it in place here. And just remove that. Here we can see a PCB and a tiny little piece of foam used as a spacer. Oh, there are the push buttons. They printed them nicely. But where is the processor? So here's what I wonder. How do they upload code to these things? Because these electronics, they don't have a port or anything. So my question is this the processor and how do they get code on it? Okay, but before we do that, let's have a look at the display. I guess this is the display. What kind of display is this? Oh, I broke it. Oh, wait, no, look at that. It's just an LED, I think. Yeah, it's just an LED and this is a piece of plexiglass which works as the backlight. Because this... Okay, wait, so if we put the batteries back in, and I press the light button, this LED should be turning on. But this button, yeah, and we're right. And once we put it in here, come on, it was in there, right? Okay, let's try that again. And we have a little backlight. That's pretty cool. Let's take it out again. Here's the display itself. And it seems to be, it's pretty heavy. This is glass. It looked very bendy when I was taking it apart. But the electrodes, wait, can I see this? It looks like licorice. The electrodes seem to be in there, so let's try. Wait, how was this connected? So this was in here, and then we had the backlight over top, and then this thing was just plopped on here, right? Or did I put it upside down? I think I put it upside down. Let's try that again. on here. Yes. And then put this back. Is this right? What happens if I... So I do think it was like this. So then this is just against here. Oh, yeah, look at that. Wow. When I press a little, we can see the numbers appearing. But it's not perfect because I removed the screws, so it's of course not aligned. How does this work? I'm genuinely amazed by this. What displays are in alarm clocks? It's not a LED.
It's also not liquid crystal.
Is there some documentation online? Is it maybe on the PCB? Is it this? This is definitely not it. How do I figure this out? Okay, I'm gonna... Glass alarm clock display. Or it is LCD. This is LCD. LCD display. It's a flat panel display. I see. Displays for a small number of individual digits or fixed symbols, as in digital watches, i.e. alarm clock, can be implemented with the independent electrodes for each segment. See, because I was wondering how come it's so sharp, but the digits are built in. Okay, that's very interesting. How do they make these things? Photolithography. Okay, so the individual symbols are kind of carved out, is what I'm getting from this. I found this awesome video of a guy making his own LCD. I left a link to that in the description, so definitely go check it out. Moving on, so we have the screen, we have the little LED, but we don't yet know what computer runs it. What do I want to know? Let's keep it simple. What is the black circle on a PCB? The black circle on a printed circuit board is a chip-on-board assembly, which consists of bare microchip connected directly to the board and hidden under a protective drop of black epoxy. So we were right that the chip is indeed under here. Now, so we know it's called chip-on-board assembly. How is code uploaded to chip-on-board? COB, let's specify chip-on-board. Uploading code to a chip-on-board assembly where an unpackaged bare microchip is wire bonded directly onto a printed circuit board. And yeah, we just saw that. Okay, pre-programming the die. What die? So they upload the code before cutting the silicon wafer via factory tools. What kind of tools? So this I get, that you add ports. I'm really curious how they upload this code. I totally read over this, but apparently they use these pins called pogo pins, which are these spring-loaded pins that can press onto the electrodes of the chip. Moving on. So I've heard that these little lines are called traces, and they're basically just copper wires that are built into the PCB. These buttons just have 2 wires running to the chip. So do the electrodes for the LCD display. LCD display. Is that double? Liquid crystal display. I wonder what these do on the ends. Because if this is on here, then those are ends, but I think these would be the ground. Just like I saw when building my own prototype, the LCD display has a lot of ground wires. I'm really curious what's supposed to be here, because it's just like the other ones, except there's nothing connected to it. Perhaps they just recycled the board instead of making their own. There's also no clue as to what should be here. So we have the screen, we have the battery, and that's it. Okay, so it's actually much simpler than it looks. I'm really looking forward to having a go at designing my own PCBs. I want to try something. I want to check if this is the thermometer, but I can do that once I hook it back up, and then I can hold this in my fingers to see if I can drive up the temperature. So let's put it back together and check the thermometer. So it seems to be working fine. Now, let me test the thermometer by holding it. See if the temperature goes up. It went down. Wait, let me try something. I'm back with a hot cup of coffee. Okay, let me try heating up my fingers. Aha! As soon as I touched it, the temperature shot up. Let's try that again. I'm beginning to think this thermometer updates like once every minute, which honestly, that's understandable since it has to run off 2 AAA batteries. Well, let's just put it back together. You know, that wasn't the surgical procedure I was hoping it would be, but I did learn a couple of things about what a mass-produced product looks like. So yeah, if you thought that was interesting or learned anything, definitely make sure to like and consider subscribing, because I'm planning on building an upgraded version of my prototype soon. So if you're interested in that, I hope to see you next time.